γνωρίζετε, η συγκεκριμένη διάλεξη θα δοθεί στα αγγλικά, οπότε θα ξεκινήσω κι εγώ από τα ελληνικά στα αγγλικά. So, good afternoon, everyone. Thanks very much for joining us in this seminar. Today is a great pleasure to introduce you Professor Yaser Abunnasr from the American University of Beirut, the Metropolitan Landscape Research Laboratory. Let me turn on my camera as well and share video. So, Professor Abunnasr is a good friend and a collaborator from the past. We worked together in the Medscapes project back in 2014-2016 in an attempt to bring landscape character assessment to the eastern part of the Med, with significant success, I would say. Professor Abunnasr is an associate professor of landscape architecture and environmental planning at the American University of Beirut. He's the associate dean of the Faculty of Agriculture and Food Sciences, Department of Head of Landscape Design and Ecosystem Management, Program Landscape Coordinator of the Landscape Architecture Program, the first accredited program by the ASLA outside the US worldwide. He's also a senior research fellow at UCL UK, trained as an architect, landscape architect, and a planner, and holds degrees in all these fields. His research and practice is on adaptation to climate change in cities, ecosystem, and cultural landscapes, with a focus on ecosystem-based adaptation approaches. He's the co-author of the book Planning for Climate Change, a reader in green infrastructure and sustainable design for resilient cities. Dr. Abunnasr is currently working on the urban heat island, local climate change phenomenon, and its implications to retrofitting cities with adaptation measures that account for social inequities. He's the founder of the Metropolitan Landscape Lab at the AUB, and lectures internationally, published widely, and continues to advise master's and PhD students on related topics. So without any further ado, the floor is yours. Yes, sir. Thank you. And then you're back to need to share. That's fine. And then you're back here.
Yeah, sure.
Oh, cool.
Thank you, Professor Yanis. Thank you for the introduction, and I'm really glad to be here, reconnecting with you and reconnecting with Cyprus as well. Welcome to our audience, and I look forward to this presentation. And hopefully we'll be able to share with you some interesting notions about adapting cities to climate change, as well share a bit of our research that we're doing in Beirut. That's, it's based in Beirut, but it's not focused only on Beirut. So, today our outline, the headings that I will be discussing, why we are focusing on cities and why are they important in the context of climate change. What is climate change and some of its impacts, then specifically impacts of climate change on cities, then what are the different notions of adapting cities to climate change. Then I will focus a bit more on nature-based solutions for city adaptation, and then I will conclude with some concluding remarks and where we're going with our research as we move forward ahead. So there are really two reasons why we are focusing on cities. Number one is that because right now half or more than half of the world's population are living in cities, and these populations and a lot of these populations are highly vulnerable. And second is that cities are usually warmer than their surroundings due to factors that trap and release the heat, and lack of natural cooling influences such as water and vegetation. So in many ways, cities are a challenge, but as well, opportunities reside there for us to really try and do something about it. The IPCC report produced this very interesting visual about the causes of heating in cities. So these are city geometry, which is the building density and the way the city is laid out. heat from human activities, from cars, factories, electricity generation, and then heat retaining properties. As we all know, most of our, specifically in the Mediterranean and the Eastern Mediterranean, a significant number of our buildings are built up of concrete, of glass, of asphalt for our roads, and this is material that really traps the heat and does not release it quick enough to really cool things off. In addition, there is a lack or absence of water in that sense, seas, rivers, lakes, and irrigation. And as we know, a lot of these have been either canalized or put underground. And there is a lack of vegetation, loss of parks, forests, and gardens, and so forth. So the accumulation of all these factors tend to make cities warmer than the surrounding. And these actually have nothing to do with climate change, all these factors. But try and think about if this is compounded additionally with climate change, what would actually happen. So, I will start, since I'm an academic, I really need to put some definitions out there, and I think important, and I'm not sure how many of the audience are familiar with formal definitions. But, if you look at climate change is not only attributed to anthropogenic, our activities only, but there is also natural variability. But the trick, the key point here is that the climate has changed in the last 150 years in a very quick pace, while the similar change that has happened historically due to natural variation would actually happen over centuries and not actually over more than centuries, even millennia, and not over 100 years and so forth. So, trying to look at the impacts, and that's, I think, one of the key issues that we really need to be thinking of. And here I intentionally bring in the natural systems and human systems, although this presentation is focused on cities. But we really cannot ignore natural systems, since cities actually displace natural systems, and because of this displacement, you have this increase in temperatures. So impacts on natural systems include changing ecosystem structures, biodiversity loss, species range shifts, changes in time, phenology, extinction, changes in provisioning of services as we move forward. And on human systems, water scarcity, food production, health and well-being, and obviously all connects back to city settlements and infrastructures where our species actually resides. Looking again at the IPCC report, and if not everyone is familiar, that's the Intergovernmental Interpanel on Climate Change, Governmental Panel on Climate Change that issues reports every 4 or 5 years on the state of climate change. And they have just issued a new one this year that's not in its final form yet, but there are a lot of interesting points there, and there's a change of how they actually are presenting the issue. So if we look at near-term risks, in the last period we've definitely increased up to 1 degree, more or less. There's a range of variability between 0.8 to 1.2. Global warming is likely to reach 1.5 between 2030 and 2040. And, these are not very far dates. We're talking in 15 years or 18 years. And reaching a 1.5 degrees global warming will cause unavoidable increases in multiple climate hazards and multiple risks to ecosystems and people. The risk level will go up. Vulnerability, exposure, and socioeconomic development and adaptation. Actually, the risk level will all depend on what we do from now till 2040 or 2050, as this will impact vulnerability, exposure, socioeconomic development, and adaptation in general. Near-term actions will substantially reduce projected climate change. So this is why there's a really big rush as to why we really need to do something now, because what we do now, we're not eliminating climate change. Climate change is here. But we will be reducing the extent of climate change, which means that if we do something today, we will reduce the risks and we reduce the vulnerability of our species and every other species as well. If we look at the mid to long-term risks, that's beyond 2040, all depends again on what we do today. And climate change will lead to numerous risks, as we have said, and there are increased risks that we could be looking at, more than 127 key risks other than the secondary risk or subsidiary risks. And again, these include biodiversity, damage to transformation of ecosystems, risks in water availability, Food security, increase of displacement with intensification of heavy precipitation. And that's, you know, I'm not sure if you've heard of the term climate migrants, and that's already beginning to happen, and it's going to increase as we move forward. Associated flooding, tropical cyclones, drought, and so forth. So the magnitude and rate of associated risks in the future, I mean, again, I want to really reiterate that it really depends on what we do in the next couple, 15 years or 20 years. Again, there are a couple of slides here, and this presentation and this whole thing will be left for you to look at. I will not be going into the extreme details, but I've chosen to really look at some impacts on human systems. If we look at health, extreme heat will increase dehydration of people, organ failure, cardiovascular disease and death. Increasing temperature will increase higher hospital admissions, mood disorders, and so forth. Extreme weather events will increase mortality rates, and so forth. Infrastructure and basic services will be subjected to high levels. But if you think at all of this, this impacts insurance rates. Things will really skyrocket. It really begins to become completely unaffordable to a lot of people. So the impact of, although we're talking about direct impacts of climate change, but there are additional sub impacts that are not directly attributed to climate change, but are derivatives of these direct impacts. If you look at the impacts on urban environments and key infrastructure, multiple climate and non-climate hazards impact cities. And what we mean by that, and this is exactly the phenomena of cities. We said cities already hotter than their surrounding, but if you increase that temperature, your global temperature, then cities will also even be much higher. So think of cities like Dubai, where, you know, right now or going into this transition season towards the summer, temperatures start going towards the 30 and the 40 and even more. Normal temperatures of 45 and 50 become normal temperatures there, and these are elevated due to the physical properties of cities and the climate itself. Hot extremes will include heat waves intensified in cities. They are aggravated by air pollution events and limited functioning of key infrastructure, and we will come into the specific impacts on cities, and air pollution is one of the big ones as well. There will be observed impacts concentrated among the economically and socially marginalized. So climate change, and I'm not sure if everyone is familiar with this term, is an equity issue. It's an equity issue at the level of the globe, and it is an equity issue at the level of communities, and it will be an equity issue between individuals as well. So when we talk about the marginalized communities, we're talking about informal settlements, camps, refugees, the disadvantaged socioeconomic groups as well. In addition to actual hard infrastructure, that will be extremely impacted through extreme events as well as slow onset events. If you look at roads, communication, and so forth, or extreme events, these will actually create a lot of damage, but at the same time, they will be, the level of deterioration will be faster, the level of sun exposure will be faster, and so forth. Looking at the economy as well, there are some positive and negative impacts to that. If you look at agriculture, in some areas you will have longer growing seasons, and some regions will benefit from lower energy demand because they become a bit hotter. If you will look towards the northern latitudes, at the negative level, it harms individual livelihoods directly. It impacts agriculture, forestry, and fishery across most of the globe. There are more assets that are exposed to extreme hazards. And there is, in general, at least in the short term, until economic systems adjust, there will be a slow growth as we move forward. So what can we do? When we talk about climate change, there are two key terms here that are extremely important, which is mitigation and adaptation. Mitigation is the, as defined by the IPCC as well, is the anthropogenic intervention to reduce the sources or enhance the sinks of greenhouse gases, which means that we need to eliminate the sources of greenhouse gas emissions. Adaptation simply recognizes that climate change is already here, and we really need to adjust within natural and human systems, the way we actually do things to these increased temperatures. So these are two key strategies that need to be followed, and they are not exclusive of one another. They overlap in many areas, and they actually are different in different areas, as we will see in the next couple of slides. Mitigation is a global, is usually, I mean, it's not necessarily global, but it is global. What am I talking about? So increasing temperatures, when we say increasing to 1 degree or 1.5 degree, that's an average across the world. And for us to be able to reduce it or curb it at these levels, we need all our countries to agree. And if you look to your right, there has been meetings since 1972 until Glasgow, until the COP26. You know, but every time the politicians sit and meet, and they supposedly agree to new targets, but we haven't been achieving sufficiently enough. So at that level, it is a global, it's a global agreement across all nations that needs to be there, where we all agree we need to reduce CO2s or create new sinks for that. And that will impact the way we do policy as we move forward. And there are several pathways to that. There are the social aspects that we really need to look into. So it's behavioral choices that are important. There are important innovation and technology explorations that we need to do to be able to develop those sustainable development goals, to be able to achieve them. And there is the whole mitigation aspect itself, where we can actually cut the sources of CO2. You know, moving to renewable energies is one of them. Changing the way we drive is important. Not being dependent on carbon fuels is another important part. At the same time, we could be able to create sinks where we can capture CO2 that's already in the atmosphere. And one of the most important things is to really avoid releasing even more CO2, like the cutting of the Amazon forests. That's one of the big issues right now, because every time a tree is cut, more CO2 is released into the atmosphere. When we look at adaptation, adaptation is an important, it should be done in parallel or in conjunction with mitigation, because as we said, global climate change is happening all across. It's an average across the whole world. But when we start looking at specific countries or regions or cities or neighborhoods, the physical aspects, the social, economic, and cultural and environmental aspects of those localities play a big role, where they interact with the changing climate, play a big role in how do we adapt to certain impacts. And the impacts, when they are brought down to that specific location, they may be perceived or seen in a different way. So in human systems, we really need to moderate the harm and exploit beneficial opportunities in natural systems, by which human intervention may facilitate adjustment. There are some current adaptations that are happening. It's not sufficient enough if we really need to meet the deadlines that are looming in the near future. So there are also several types of adaptation approaches. There's the anticipatory approach and the reactive, the autonomous and planned, incremental and transformational. I'm not going to go into all of these details, but they all boil down to: we plan for the adaptation? Do we just react? Most of our politicians, there's a high, let's say there's an increase in heat waves, then suddenly a new policy comes up, and then, okay, now we've adapted to that. But that's not sufficient enough, because that's a reactive approach. If we anticipate, if we plan beforehand, then we can really, and using evidence and using science to really push forward these adaptation plans, then it might become extremely important for us to move forward. And there are incremental adaptation measures that can be done, and there are transformational, but working towards an incremental approach that really builds up into a certain transformation into the near future is a very valid approach for adaptation. One thing we really need to be very aware of is maladaptation, and again, I'm not going to go into full details, but there is always the risk that we want to adapt to increasing climate change. A very simple example is when temperatures go up, we tend, especially in our part of the world, we tend to turn on our ACs to blast our air conditioning, but air conditioning actually emits greenhouse gases. So this is really not a really proper and appropriate and sustainable adaptation tool. And again, somebody might ask, how do we cool off? How do we stay cool? These are difficult questions that all of us, individuals, communities, we really need to try and answer one way or another. So one thing that is really put forward from recent IPCC reports is the climate resilient development. And again, this really touches upon several layers that really brings in the social dimension, environmental dimension. I'm just putting it forward to you because a lot of what I will be discussing later on is very much related to this in more detail. But this is the overall framework that is put forward that really brings together climate action, different pathways that really need to be put in the way we do development, and the way and that resilience in itself should be a target in the way we actually approach all of this. And there is always a question, can you be resilient and sustainable at the same time? That's a much bigger question for another presentation. So what are the impacts of climate change on cities? Again, we look at, and this is, we're focusing here on cities in specific. So we're looking at multiple dynamics and multiple interactions within cities. So the main hazards identified for cities and settlements and infrastructure, there is a more frequent occurrence of extreme climate events such as heat waves, more hot days and warm nights, more water scarcity and security, sea level rise and air temperatures rise projected to occur in most coastal settlements, increase in rainfall intensity that will increase the probability of coastal city flooding. And here it's a key point when we talk about sea level rise and coastal settlements, because as you know, historically, most of our cities, were coastal or on major rivers, and that because economies depended on shipping, on seaports and so forth. So all our cities, specifically in the Mediterranean areas, are all susceptible to all these impacts. There are several key risks, and again, there are many lists and long lists of all of this, and there's a lot of discussion on this, but I will really try and focus on three key areas: the dynamic interaction of urban systems with climate, looking at urban heat island and flooding, looking on risks on human vulnerability, poverty and vulnerability as well, risks on key infrastructure, urban infrastructure, and urban ecological infrastructure. So I'm not sure if everyone is familiar with the term, but the urban heat island is basically where cities are warmer than their surrounding, and this is due, as we said before, to the nature of the material itself. So if you look at the red line, this is the normal graph or the normal projection of any city urban heat island. It's hotter in the middle, but cooler on the periphery. When climate change hits, dotted line shows you a total increase. So if you were at 29 degrees, you're going even further. This is, very indicative only, not based on data, but you will be reaching higher extremes, temperature extremes. The urban heat island is amplified, and one of the most important things is diminished indoor and outdoor thermal comfort. We all are comfortable within a temperature range between 20 to 24 degrees. Once 26 is acceptable for our part of the world, even 27. But once you start hitting higher degrees, then it really becomes completely uncomfortable, and that impacts your productivity and your function. Just out of courtesy, I put a plan that shows the urban heat islands in the 4 major cities of Cyprus, and if you look at the differences of color, you can see differences of temperature, at least for Nicosia, looking at around 3 to 4 degrees difference. For Paphos and Limassol, much less, and that's also proximity to the sea plays a big role because of water current, air and water currents as well. So looking at urban flooding as well, it's again because of the nature of cities, because we have sealed surfaces of concrete and asphalt. We all know when it rains, it floods, and you get these urban rivers within streets, and they are amplified when you don't have proper drainage. But based on the projections that there will be increases in precipitation, which means more volume of water coming down, which means that less water is being percolated into the surfaces. So that becomes a problem for internal flooding within the cities. If you look at low elevation coastal cities, are subject to sea level as well. informal settlements, and that's a big question in climate change, looking at disadvantaged communities and informal settlements. These will be impacted highly. Smaller settlements along waterways, small island states within maritime populations, and large cities located in coastal deltas. So, if you look at the graph to your right, this shows the changes in the number of damaging floods in the countries surrounding the Mediterranean Sea since 1920 till 2020, and you obviously see an increase in the number of events and the severity of these events, since at least 50 years until today. Again, there will be also issues of water scarcity. There will be and water scarcity. Again, I'm not sure if everyone knows, it's not only just water availability, it interacts with how do you distribute the water to different populations, it's how much goes to irrigation, the whole water balance formula. So a lot of land use changes will impact that, migration to cities, and due to conflict and due to climate migrations that are going to actually happen very soon. And there will be changing patterns of water use, including over extraction. So there will be effects on the supply and demand, and it's projected that 1/3 of all major cities worldwide will exhaust their current water resources by 2050. And not necessarily only because of climate change, but climate change will compound that effect and will make it faster, actually. So there are a lot of other dynamics that will happen, cold spells, landslides, wind, fire, and air pollution, which I'm not going to go into here, but you may be surprised about cold spells, but even if the world is heating, there will still be areas that will have these extreme cold areas that will affect also vulnerable communities, either the elderly or the disadvantaged as well. So looking at urban poverty and vulnerability, and this is where we really talk about climate migration, climate change as the great displacer. And this was a study that was done that shows possible migration of peoples across different nations and different continents due to climate change. And it is projected that around 170 million people, 1/3 of populations, will actually be moving. And when we look at, and I'm bringing the human factor here because, that's extremely important for our policymakers, for our city managers to really begin to see the overall story. So higher temperatures, will also reduce labor capacity. Your agricultural productivity, for example, will be reduced by 20%. Today it's around 10%. These are very generalized figures, but they give at least, a general trend by 2050. Cold spells will really impact elderly populations. Water scarcity will impact everyone. Extreme winds in urban areas can have particularly damaging effects on poorly constructed buildings. And here, extreme events is not only due to natural causes, it's also because of what we call the canyon effect in cities. So if you have two buildings and a street, it looks like an inverted U. So that's what we call the canyon effect, that really tends to really push air into the city. In many ways, it's good for ventilation, but when it reaches certain speeds, this canyon effect augments these speeds as well. Another important piece here, I just wanted to bring this in, is that there are really data gaps when we talk about different communities. The more affluent, the more economically secure, we tend to have more data about, much less about urban poverty and vulnerability. And that's an area of extreme focus, important focus for urban planners. We tend to talk about the physical dimension of cities, which is extremely important, but at the same time, we tend to forget about the poorer communities or the communities that have issues with accessing, with being able to be, secure at multiple levels with proper livelihoods. Looking at energy infrastructure, climate change will influence energy consumption patterns, so we really need to be very careful as we move forward. As I was giving the example of the air conditioning systems before, we will need to use more energy, but it is very important that our source of energy should change. Urban ecological infrastructure, or what we're talking nature-based solutions that we will touch upon later on, is an extremely important measure for cities to adapt, but at the same time, As we know, nature-based solutions are natural systems. They are also susceptible to climate change. There will be impacts on climate change, either through disease, either through water scarcity, insufficient water for irrigation. There might be some species that grow today in Nicosia. In 40 years, they may not grow here anymore, and so forth. So we really need to be very careful to, to really and maintain the health of our ecological systems, because they improve the resilience of any city, of humanity, in addition to other species as well. And again, where you have natural infrastructure that is occurring, when we're talking about wetlands, mangroves, or estuaries, urban trees and forests, and coastal natural infrastructure, it is extremely important for us, as individuals, as scientists, as planners, as managers, as policymakers, to really keep in mind that, again, this is the base of our survival. The natural world, ecosystems are the base for us. And if we really don't maintain them, in addition to the ecosystem services that we can, attain from them, it is extremely important to really maintain their own health as well. And again, climate change is a lot about contradictions, as much as there are impacts, but in certain areas, trees and vegetation within cities have grown to extreme extent, and these are good things for us because they can become CO2 sinks, and this is why everyone is talking about increasing vegetation cover in cities. And there are issues with that we will discuss as we move on. So when we're talking about adapting cities to climate change, we're linking ecosystems and urban systems together. So management and adaptation pathways are composed of sequences of actions connected through collaborative learning with the possibility of enabling transformations in urban systems. I would like to focus on the word collaborative, which is something we don't do enough as a humanity. I'm saying not us here in our context only, but I think worldwide. Climate change would require collaborative working together. But what is even more important is learning, because we are going into waters, uncharted waters. We really don't know much about what the future is going to happen or which path it may take. And sharing information, sharing data, sharing evidence is an extremely important piece of the whole formula for us to be able to combat climate change at the mitigation level or even at the adaptation level. So if we look at management and adaptation within cities, we need to look at the three pillars of infrastructure, if you want to call it. And I'm using the word infrastructure here either at the physical, ecological, or social infrastructure. We're using the word ecological here to also mean nature-based solutions. That that's a term I will use later on as we move on. So these are three components that are enablers for us to be able to adapt cities to climate change. So the physical infrastructure, we're talking about how the city is built, the form of the city, the shape of the city. How do we use the land? How do we use the urban land use planning, building and design? So what type of buildings are we doing? There's a whole trend of climate responsive building designs that is really emerging and very strong. Information and communication technology, energy, transportation, water sanitation, and coastal management. These are all important pieces that really intersect and overlay as well with ecological and social infrastructure. When we talk about ecological infrastructure and the ecosystem services that they provide, most of you probably know temperature regulation, air quality regulation, stormwater, coastal flooding, riverine flooding, water provisioning and management, and food production and security. And at the level of the social infrastructure, livelihoods and social protection, emergency and disaster risk management, climate resilient health systems, education, and cultural heritage. The reason why I'm naming every single one of them, because if you, if this is on a blackboard, on a whiteboard, and you start connecting it through different lines, we'll see that all of these intersect together, and there is really no point in only looking at energy without looking at, how can we reduce energy using ecological infrastructure to shade our buildings, and if we shade our buildings, then we can provide thermal comfort for people living inside or outside buildings. And that's one of the simplest mundane examples I'm giving. But all of these three pillars are interconnected, overlaying, and it shows you how complex the whole system. And in our real world, we tend to simplify all of this too much, I think, and it's extremely important that we really should bring that complexity back into our thinking. So if you look at physical infrastructure, and the next three slides also, would be good for anyone to actually look at them, because they give a summary of what actually these adaptation or management strategies are. So if you look at urban morphology and built form, we need to look at our street canyons, increasing surface albedo, built green design configurations. And as we will see in our research, I will show you, the finger-like developments tend to be the most, least generating of heat, for example. If you look at land use planning, looking at zoning regulations, policies, and land use measures that look at, sustainable growth management, looking at compatibility of uses within urban land, looking at building design and construction, architectural and urban design regulation at the single building scale. There are, for example, I completely forgot which island, but they have changed their regulation to actually build every single building on what we call pilotis or columns, so that because, the flooding level, because the island is so low and the flooding level is so frequent that there is really no point anymore, in building ground floor floors. So they actually simply raise the whole thing. Looking at passive cooling, meaning that looking at traditional systems of how our ancestors cooled their houses, especially in our part of the world and even desert areas, through wind catchers and solar chimneys and air vents. Looking at information and technology. I'm not going to go through all of this, and I'm sure the administration here at the university could provide this if you really need it. Looking at social infrastructure as well, livelihood and social protection. Looking at adaptive safety nets, social insurance, labor markets, and so forth. Looking at emergency and disaster risk management. Looking at climate resilient health systems. Looking at the World Health Organization operational framework, a lot of people are beginning to think about all of this. Looking at education and communication, how do you present climate change education? Where do you bring it in? At what level of in schools? How do you make people aware? Looking at older generations and the disparity between different generations and the knowledge base that they have. Looking at cultural heritage and institutions as well. And if we look at ecological infrastructure as nature-based solutions, some of the important, strategies are temperature regulation through street trees, green roofs, green walls, and so forth. Air quality regulation through street trees as well, selecting species with low volatile organic compounds, low allergens emissions and high pollutant deposition potential, looking at stormwater regulation, looking at urban parks and open spaces as well, looking at biospheres. So these are all examples of nature-based solutions, ecological infrastructure that really, really support resilient adaptation to climate change. And again, this is talking about ecological infrastructure is not an easy thing to really achieve within urban areas. Urban areas have very dense soils. Urban areas have high levels of pollution within the ground, within emissions from cars, and so forth. And really putting in a viable ecological system is as complex as building a dam to retain water on a river, for example. And again, there are challenges to this, as we will see as we move on forward. So looking at nature-based solutions for adaptation, and here I'm trying to formalize a little bit what we are talking about. So jumping from our previous slide that really looks at the three layers of infrastructure: the physical, the social, and the ecological. I'm trying to focus more now on nature-based solutions. The formal definition by the IUCN are nature-based solutions are actions to protect sustainably manage and restore natural or modified ecosystems. And I would like you to focus on the word modified ecosystems, because this is what they are in urban contexts. Although they look natural, but they are modified, they are man-made in many situations, unless they are left over natural parts within a city that address societal challenges effectively and adaptively, simultaneously providing human well-being and biodiversity benefits. And again, from the beginning of this presentation, I've been talking about natural, urban, human, natural. And that's an extremely important notion for us to keep in mind. We cannot really separate these systems anymore. These are interconnected, intertwined, and there needs to be comprehensive, holistic approaches that really bring all of this together. Again, I'm not going to go into these types of nature-based solutions may include, but again, just between parentheses, when we talk about nature-based solutions, I'm focusing here on urban context, but there are a lot of nature-based solutions that apply for agriculture, for example, like agroecology approaches, dealing with pests and so forth, through ecological systems, like our ancestors used to do basically. But since I'm focusing here a bit on cities, anything that we bring together, parks, street trees, green roofs, swales, urban forests, greenways, green belts, coastal reefs, and dunes, can be, and I here specifically say can be, because you could create a park that is planted with native plants, that I could have imported these trees and plants from somewhere else. But this cannot be, and it might perform certain ecological functions, but it's going to be a little bit foreign to that context, and that cannot be categorized as an ecological infrastructure per se. So we really need to be careful about how do we bring these nature-based solutions to urban contexts, and how do we put them together. So why is NBS suitable for city adaptation? I like the word complementarity, and I have a very simple table that just puts the nature-based solution ecosystem service to your left and the climate impact it addresses. It's like a complete match together. So it regulates temperature, but climate impact, we have increasing temperatures, increasing urban heat island. We have air quality regulation, we increase pollution to heat trapping, and so there is a lot of alignment. And again, I want to just also to emphasize that although I'm a big proponent of nature-based solutions, but I also realize that nature-based solutions cannot be the only solution for adaptation. And this is again why I was discussing earlier nature, ecological infrastructure, social infrastructure, and physical infrastructure. The combination of these three can lead us to possible adaptation paths that are viable, resilient, and sustainable. But my research and my focus is on nature-based solutions. That's why I'm really looking at it. So if we look at, as nice and lovely as it sounds, and we all love the green color, I believe, there are also challenges for nature-based solutions. And this is where our research in Beirut at the Metropolitan Landscape Research Laboratory have been working. So some of the big challenges are prioritizing NBS in policymakers' agendas, and these are partially due to either time, financial and time mismatch between reality and policymakers' agendas, physical space for NBS in cities, and basically here the whole notion of this is that to really effectively clean water, you really need large areas of nature-based solutions, of constructed wetlands, let's say, or pervious surfaces planted with a lot of shrubs and so forth. So for the same surface area of a nature-based solution to clean a certain amount of water, you would need much less in conventional, or what we call gray engineered infrastructure. And space in itself is an extremely important one, specifically in existing cities, especially also in historic cities, which is very much the context of the Mediterranean area. In addition, looking at health of nature-based solutions, they are living systems. Let's always remember that. They are, biotic and abiotic components that really interact together, and it is extremely important to maintain that health. Another big challenge is measuring the ecosystem benefits of NBS. To be able to really convince policymakers of the benefits of NBS, we really need to give them numbers and figures. And again, here, I'm not saying that we really need to be slaves to the policymakers. That's not what I mean. But since our governance systems today currently work this way, and it is through these policymakers or these city managers that decisions are taken, we really need to really address how they think and how they approach matters a little bit differently from scientists or designers. And that's for a good reason as well. Looking at availability of appropriate scale data for NBS implementation. So having available data that is at an appropriate scale for cities specifically is extremely important. I will be starting, for the next 10 minutes, talk a little bit about our research. And if you look at, these five headings over here, these will be the titles of the upcoming slides as we move forward. So looking at prioritizing nature-based solutions and policymakers' agendas. So one piece of research looking at the lower diagram to the right, this was done a little while ago, but we tried to take nature-based solutions, the whole idea of looking at how natural systems are hierarchical and interconnected, and trying to apply it to say to policymakers that it is extremely important to look at policies as interconnected systems. This is at one level. But at the same time, we really need to be able to address certain specific impacts related to the morphology and the physical relationships of the cities and where these impacts are. And we developed what we call the Green Infrastructure Transact. Some people are coming from ecosystem management or natural resource. I'm sure you're familiar with the Ecological Transact as a use as a tool for for sampling and working in natural areas. We've adopted that idea, and there's also the Urban Transact. We've actually merged these two ideas together to try and develop an approach that really tries to direct policymakers and planners and scientists as well to try and look at the different areas within cities. So if you look at the coastal area, it has a different physical morphology, looking at an urban core and the urban and then the peri-urban areas. And obviously, as you move forward from the urban core towards the peri-urban, you will end up with more spaces that will allow you to really incorporate nature-based solutions. But the idea here is that this is all one continuum rather than looking at these at different sectors. And this methodology actually was developed on the city of Boston in the US with some collaborators over there. And it has been applied in two actually cities in Canada to try and see how they can actually develop nature-based solutions within their cities. The other diagram, which is on the upper right, this is looking at a whole network, although not 100% nature-based solutions, but looking at urban agriculture as a social layer within urban systems. And if you look at this, you might say this is a road network diagram. This could be a communication diagram or an open space. But what we're trying to really put together here and send the message is that it is not acceptable anymore for urban planners and urban policymakers just to look at road network, buildings, communication, and transportation, and that's it, or energy. We really need to incorporate the ecological infrastructure into this system, and this whole idea was applied to a neighborhood in Beirut that is a mix of transient laborers that actually live there, and a lot of immigrants that are coming into that area. And it is addressed towards improving overall well-being. We all know that urban agriculture within these very tight spaces will not support daily diets of very dense communities or very intense areas, but they will provide the space for people to interact. They will provide part of their food. These systems actually provide areas where water can percolate and rejuvenate the groundwater levels, and so forth. So depending on the urban context, there are different benefits that can be accrued from these systems. The second point that I would like to focus on, and we've done a lot of research here at multiple levels, is looking at how do we define, how do we develop physical space for MBS in cities. Sure, you've heard a lot about somebody has built a green roof here, made a rain garden somewhere, or built a green wall somewhere. These are all important local scale interventions. But if we really need to try and make an imprint or to try and transform urban temperatures and really reduce those temperatures, it is extremely important to try and look at the city, not necessarily within its administrative boundaries, but actually beyond its boundaries, looking at the urban region as a whole, to try and really understand where can we increase those nature-based solutions. So if you look at this diagram that is in front of you, and this is a very simplified diagram as well, trying to categorize land uses and land covers within cities into two categories. And it's intentionally simplified policymakers. And what we're calling the pervious surfaces, which are surfaces that are not sealed by urban materials, either concrete or asphalt or building, and the impervious surface. And for each one, we have two strategies that we have worked on and continue to work on. One is expand pervious surfaces, and the other one is intensify. When we look at expanding, at the impervious surface level, you have to reduce impact, which means reducing the amount of impervious surfaces or transform some of it to something else. So if we look at the pervious surfaces, we're looking at expanding, meaning, if you have, let's say, a public land or a park, you protect that and you try and increase and with an intentional strategy from any city to really start buying more land, basically. And here we tend, when we talk about nature-based solutions, we usually tend to talk about public land. Private land has a high contribution level to increasing ecosystem services within cities. While this is usually not included in the stock of the way we calculate NBS, but it is extremely important to include. And there's a fantastic example in Berlin, for example, which is what's called the Biotop System, which really is an incentive-based system to allow private owners not to pave their gardens, for example, and to leave it, with soil. And then also to increase, either put green roofs or green walls. And the incentive here is that their property tax will be cut by a certain percentage depending on how much pervious surface they allow within their land. By intensifying, meaning increasing vegetation, increasing the urban tree canopy, shrubs and ground covers, and then reduce at the impervious level, reducing impact, meaning that we have a lot of, and we still need impervious surfaces, at least for the time being, until we invent cars without wheels that can hover and move from one place to the other. Until today, we still need asphalt roads. But what we can do about these is that we can shade them, either at least at the parking level. We can create ground cover, making parkings, let's say, gravel or some kind of planting. We can also reduce standards. As an example that I'm familiar with when we talk about planning standards. In the US, for example, I'm sure, I don't know how many know, but in the 60s and the 70s, the American car was a humongous car. So the parking spot for an American car was double the size of a European car. But now they are getting reduced, but the standards of planning remain from the 70s. So if you change that standard today, let's say in the US and other areas, then you really can cut down on the level or amount of impervious surfaces. The other strategy is transforming. And here what we mean is the green roofs, green streets, green facades, and green parking. And here trying to replace the impervious surfaces with pervious surfaces. And the combination of all of this framework that we've been working on, has led us to 2 or 3 research projects that we've worked on that I will briefly share with you in that sense. So again, this started partially with a Boston collaboration, and Again, our first idea was to develop metropolitan scale. Boston is around 7,000 square kilometers. If I understand correctly, Cyprus is around 9,200 square kilometers. So this is around the size of Cyprus and the same size of Lebanon approximately as well. For a policymaker to be able to take a decision, where do I invest in nature-based solutions and why should I invest? We've developed this whole methodology that takes into consideration different roof types, streets, parkings, existing vegetation areas, parks, and encapsulated forests, and that is overlaid with different socioeconomic considerations. For example, where are vulnerable communities? There's also climatic conditions. Where are the areas that are going to be heated mostly? So if you have areas that are with high temperature, with vulnerable community, then this is where you would be, this is where your priority of investment should be to increase green infrastructure in those areas. So based on this, and if you look at the different typologies, if you look at the upper diagram to your right, that shows you the different land uses from a commercial to the golf course, and that's in the context of Boston. But what this really tells you in its simplest form between its pervious and impervious variables, there is opportunity to increase vegetation in every single type of land use with different magnitudes and different possibilities. If I look at commercial areas, yes, I have less ground areas to plant, but if these are big factories and warehouses, I would have very large roofs to create green roofs, for example. So, and if you go to a golf course on the other extreme, or a cemetery, for example, there are a lot of possibilities to really increase those vegetated surfaces. So this whole system was developed to really assist and prioritize at the metropolitan scale. And this is why we are working with only 2 variables to really simplify the process without overcomplicating matters. The other piece of discussion, that relates to the same approach is looking at, and this is part of the context of the study of Dubai that we did as well, where we tried to really experiment and look at different vegetated land covers between, ground covers, trees, shrubs, and so forth, and look at their impact on outdoor temperatures. And here we focused on gated communities. Gated communities are residential areas, and in a context like Dubai, which is very, is very arid, is a desert context. Gated communities, although they are not sustainable in many sense from a social perspective and an infrastructure perspective, they provide an opportunity to increase vegetation for different reasons. One, they have their own communities for management, which means that you cannot plant in Dubai without irrigating. So that's one discussion, and they provide the opportunity to increase green infrastructure, nature-based solutions. So we looked at different shapes, different morphology. Going back to the city morphology, here we're looking at urban development morphology and looking at different types. So if you look at the left diagram, the green drawings below, you've got different, these are abstracted or stylized forms of these developments, which we show them in the photographs above. And what we found out, we used remote sensing here. We also used evapotranspiration, release, agricultural methodologies to look at this, looking at the heat exchange between the ground and the earth surface, the air itself. And we found out that the developments that are like fingers, if you look at the middle one that looks like a little octopus in the middle, these developments have showed the least imprint of heat, meaning that they are not as hot as the other examples. At the same time, they provide the possibility to even reduce that temperature by increasing those areas. And the graph to your right shows you the finger-like development, which is number C, with the least heat imprint. And that we think is attributed to the distribution of the built areas between the green areas, rather than having concentrations of green and concentrations of built areas. At the level of the individual buildings, this is a prototype that we are currently building at the American University of Beirut, and we're starting building in the next 2 weeks. looking at green walls to really to recycle domestic grey water for bathroom use or for irrigation. And you know, have been tested in the context of Italy and other more temperate climate contexts, northern Italy. But you know, this is part of an EU-funded project as well. And there are a couple of prototypes that will be built between us, Lebanon, Jordan, and Tunisia to really try and test these within you know, a more arid or semi-arid context. And again, we're also testing for domestic grey water recycling, but at the same time, we're also putting in data loggers and sensors to really try and test the contribution to the ambient temperature around these green walls, and to what extent there is a certain effect to that. Looking at NBS, that's the third challenge that we're talking about. We've been developing part of our project in Dubai as well. Was our recommendation to use native plants, and you know, one thing led to the other. As we all know, we all love to use native plants, but when you're talking at the scale of cities where you really have to plant at large scales, you need to have these plants available in nurseries. But so we did a whole survey in nurseries, and we found out that there's barely any of these trees. So we started talking with these nurseries, and that led us to develop a whole manual with native trees that could be propagated for urban use. And if you look at the fiche in front of you, that shows the calculation of all the ecosystem services and benefits that are there, from CO2 sequestration to air pollution, you know, mitigation, energy use as well, and so forth. In addition, I'm sorry, I don't have any visuals for that. I just simply missed to have them with me here. We're also looking at different species and the contribution of different species of trees, broadleaf trees, you know, needle type, and so forth, to the level of how much they can reduce temperatures in and around them. And we're looking at those with different irrigation regimes, trying to see what is the threshold that trees actually will stop delivering these ecosystem services. And hopefully, we've just submitted a new proposal for a project we're calling the Global City Forest, that really tries to look at a totally different new way of looking at urban landscapes, rather than having just simply rows of similar trees or two types of trees within streets. We actually try and look at them, or try and design them and plan them as natural systems that are ecologically viable. And this is extremely important as we move into the climate change era, because we really need, and as you know, biodiversity is not only good for us, it's important for the system itself, for its health as we go on into the future. The third one is measuring the ecosystem benefits of nature-based solutions. And again, I think I'm running a little bit too far, so I'm going to go a bit quickly here. This is one project that we're looking at, and if you notice, you see these two vertical lines here. We are currently trying to assess the delivery of ecosystem services or cooling services of trees in the vertical dimension, and we're using drones to collect this data from temperature to humidity to airspeed and so forth. We've been having a lot of challenges on how to manipulate the drone, how does it, because you know the sensors to have a good reading, drones need to hover and stop over there. So we've been in a bit of a testing area, but we're trying to develop technology to try and understand the vertical interaction of vegetation and the surrounding temperatures as we move on. As well as, you know, the third dimension we're looking at, this is again related to the Dubai project. We try to look at human outdoor comfort as well, versus we're looking at different vegetated covers. We've set up several data loggers over there, climatic units in different locations with different land covers, trying to isolate for other compounding factors that may affect us. And what we've really found out is that if you look at the dates, this is 22 May, 21 June, this is, and if you look at the temperatures to your left, you're talking about 30 degrees to 35 degrees. And if you look at the blue line, so what we've tested for are vegetated cover, bare soil, dense tree canopy, and you know, mid-level vegetation up to 1 meter. And what we found out is that after a certain temperature, if you look at the blue line in the graph, and I hope that's showing over there, which is this one, this represents the dense tree canopy. The rest of the vegetation, even in previous months, they were contributing to reducing temperatures, but they, after a certain temperature threshold within the context of the biome, they stopped doing that. And looking at dense trees, these were the most efficient, and not because of their biological properties. It's just because only of their shading properties. And the last point here that we are talking about is looking at availability of data at appropriate scales to really look at urban areas. We're looking at downscaling, what we call land surface temperatures. And to your right, we've developed different models to actually do that, from remote sensing to really allow us to capture, because what's available in remote sensing for land surface temperatures that's freely available are much coarser resolutions, and trying to really come up with finer resolutions will make our work much interesting, and for a lot of other people. So our concluding remarks with the last 2 slides, our future planned research is looking at global comparisons across the globe, looking at urban ecosystem health. We would like to also focus on the equity dimension and continue our work on measurement. As concluding remarks, nature-based solutions are no regret solutions, meaning regardless of how climate comes up later on, at least we'll have greener cities. And nature-based solutions provide co-benefits, as we have talked about, and there are the social and cultural benefits that we haven't focused on. One key point is that NBS cannot be the only way to achieve adaptation, as I have mentioned before. This needs to be coupled with other social, economic, and physical systems. There needs to be an effective body of evidence that needs to be accumulated and needs to be shared across different areas and different regions. And it's extremely important for us to look at cities beyond our administrative boundaries and start thinking of larger urban regions that incorporate natural ecosystems. That's it. Thank you very much for listening and for your attendance.
Okay. Thank you very much, Yaser. A very comprehensive presentation touching on all the challenges and issues that we have to face under climate change. Now, the floor is given now to the audience. So please, if you have any questions, raise your hands. I'll give the ability to actually ask our guests any questions you might have. So over to you for any questions. Thank you. Perhaps I should warm up the floor while some of you might be thinking of any questions. Yes, sir. Interesting, you mentioned in the beginning that climate change is also about equity. In your presentation, you talked about marginalized communities, and we know by now that the impacts of climate change will be worst on already impoverished areas. I know there are no magic solutions, but what are your thoughts on that? I mean, can we, Western societies, if you want, keep on telling the societies in other impoverished places in the world what to do and what not to do?
I completely agree with you. There is really no magic wand to really solve all of this. But I think, one of the key ideas that we've talked about is collaborative learning. And I mean, just going back to the notion of equity, equity is not only about only communities, it's also at the national level and at the global level. And if you, and I'm not sure if you followed part of the COP26 discussions, it was all about who pays who to mitigate climate change. You know, the Western countries are asking developed countries asking developing countries not to emit more greenhouse gas emissions, and we will compensate you on that. But what that means is that developing countries cannot reach the same level of development if they don't use, let's say, carbon fuels, because they cannot, you know, reach in the same pace. So that's at the global level. What will really be felt is that, as Yanis was saying, is that communities, individuals will be affected. Now, what can we do about that? And I think this really needs to come to boil down first to collaboration, sharing of knowledge from previous areas, and actively try and engage those communities. I think just simply saying, you know, the marginal or vulnerable communities will be affected and accepted, for me, that's not an acceptable solution. I don't think that there are clear solutions how to do that, but I think the first thing that any one of us can do, and any government can do, or any society can do, is reach out to these communities, understand where the issues, and really meet their direct needs first before we start talking about climate change. I know that's, you know, that sounds humongous, because I think we have large numbers of disadvantaged communities, but this is where we can start, I think, Yanis. I think as a starting point is, I don't think enough people are, enough institutions, organizations are reaching out to understand what these problems are. And there are really, you know, quick fixes. For example, if they are in exposed locations, let's say in a floodplain, or on a very steep slope where there is a risk of landslides, for example, these people can be moved. Yes, it's a costly business, but these people can be moved, for example, in exchange for doing certain work and so forth. So the solution is not only just looking at climate change, it's also a socioeconomic problem. It's also a purely economic labor type of problem as well. So I think looking at all of this needs to be looked at in a very comprehensive and holistic way.
Thank you, Yaser.
Thank you for warming up the floor.
Yeah. Anything else? Anyone else? Dimitri, would you like to share your question? You can take the mic. Like, otherwise we can read your question. No problem.
I'll read it. That's fine. Would you like to read it, or hear them? Or?
Yeah, thank you.
The question is, how much can we reduce the heat island effect based on the solution you presented for the Mediterranean cities? Excellent question. I don't think you can have a cross-cutting answer to this. I cannot say that we can reduce heat island across all Mediterranean cities by 2 degrees or 3 degrees. And the reason why I cannot say that is that urban heat island is very much related to the specific immediate physical context. So if you have a Mediterranean city that is sitting on, you know, on a coastal area, or a Mediterranean city that is at a higher elevation. If I take, let's say, Beirut, and we take Nicosia. Beirut is coastal, but it has also 2,000 meter to 2,500 meter wall of mountains just behind it, for example. And if I take Nicosia, where you have flatter area around it, which is a lot of agriculture, the potential of increasing vegetation around and within Nicosia is much higher than doing it in Beirut. So in Nicosia, probably you will be able to reduce your temperature more than we can do in Beirut. But it will not be at the same, Beirut we can reduce it probably, but it will not be at the same magnitude. The humidity, Beirut is a much humid place than Nicosia as well. That plays a big factor. Wind issues play another factor. But you know, you could easily, if there is concerted effort, and again here we are not talking only about planting 1,000 trees here and 1,000 trees there. This is about really having a concerted effort. You know, I don't know if you've heard of initiatives in Los Angeles and New York, you know, the 20 million tree planting initiative, for example. We're talking about that scale. And so that's that is something that can be done, and you would be able to reduce it by 2 or 3 degrees probably. But again, we have another challenge for us in the Mediterranean compared to your temperate climates is water. For us to really plant all these trees, we need a lot of water, at least at the establishment level. And this is why we would go with native trees. At least you would assist in the establishment, but then they can pick their own later on upon maturity. But that's also a big challenge. And this is why I'm focusing on my research on arid and semi-arid contexts, and I'm really bringing the water dimension into what we are doing. I didn't get a chance to explain much, but one of the experiments we are doing, we're taking 3 species of trees, and we're testing for different irrigation regimes to see how long these trees can survive. Can we reduce the amount of irrigation for these trees while they continue to provide ecosystem service, reducing temperature? I hope I have answered your question.
Okay, and following on from that, Yaser, I will hijack again the floor because you start talking about challenges, and that was my next question. I mean, the question was, what are the challenges of applying a nature-based solution in this part of the world? Okay, we're in the East Mediterranean. We're sitting in one of the most arid places of Europe. Okay, the gateway to the Middle East. What are the challenges? Not just the physical challenges as well, but you're a planner. I mean, how well is this integrated, if at all, in the planning process, and how can it be? Can we actually facilitate the process of integration in planning?
That's an excellent question, Yanis, and I agree with you. It's not only physical or environmental; it's also policy related, governance related at all levels. I mean, let's start a little bit from where we finished before with the water issue. Definitely, that's a big challenge. You might say, and I think if I assume correctly, Cyprus is desalinating water basically. So that's one question. But again, that's one solution. But again, we have to be very careful because the desalination impacts the salinity level of our seas, which could impact marine ecosystems. So we really need, and this is what I'm talking about, maladaptation, for example. So water is one issue. The other big issue as well, and as we found out in Dubai, is that we sit and talk about native trees, but we don't have enough propagated trees there, to be upscaled, to be actually put out there. So that's another important physical level. There's also the know-how and the ability and the knowledge of either the farmers or landscape architects or landscape managers to really comprehend that there will be transformations in the soil, the interaction between the soil and water and plants due to climate change. And we honestly don't know how that is going to manifest itself 100%. Maybe increase of temperature may reduce something or increase something, but at the larger scale, and when we're talking about interactions below ground and above ground, that's also another challenge. If we look at policy planning and policy levels, I'm not 100%, let's say, familiar with the Cyprus context, although I know you might be 1 step ahead of us or 2 steps ahead, maybe even 10 steps ahead of us, because there is lack of awareness of policymakers, number one, to these solutions. And one big important thing is that when we talk about nature-based solutions, these are natural solutions, living systems. And living systems require a bit of time to really get established. We talk about ecosystem services, but delivering these ecosystem services only happens when you have your landscape that's mature, 10, 15 years, when you still get that delivery. Look at any policy maker, any president, any head of municipality only comes in for 4 years, maximum renewable of another term, and that usually policymakers love to leave certain legacies. They cannot. Very difficult for them to be able to think long term, and that whatever they are investing in today, they will not directly reap the benefit. They will not see that benefit. So for me, that's one big challenge. And this is not for us only for our part of the world. This is across
whole world, generalized in the US, UK, EU, everywhere. Now, at the level of awareness and understanding, I know, at least from our part of the world, lack of care, lack of interest in anything called climate change and what that means and so forth. We are opening new gas wells and oil wells in and maybe Cyprus as well, because we have all these shared fields. But there is really no interest at the, we don't have a proper, even a proper planning department that actually can plan, and I don't want to say nature-based solutions, that can plan proper roads and proper other infrastructure. So there is lack of awareness, lack of understanding, and lack of, understanding that all of this could really lead to a more sustainable solution. And part of this is that there isn't sufficient research in our part of the world. Not only that, and also looking at the economic value of all of this, and looking at cost and benefit analysis if I take a nature-based solution or if I don't take a nature-based solution. So that's part of it. There's also, I think, one important challenge at the individual level for each one of us. It's not sufficient anymore to preach the other. And this is why I was talking about the social systems as well, bringing in education, and for people to really begin to understand that, it's not only about big picture, it's also about the small picture, about our children, our future generation as well, to be able to understand and act as individuals that will really maintain our planet. We have another question.
Yeah.
What could be the solution you propose so that the need for new residential areas and the space required for planting new trees coexist? I'm just going to go back to my example over here. So I don't know if can you see the cursor? I think yes. you can. So if you look at this, okay, this is what we found out. Rather than having if you look at the second column, looks a bit more dense or a bit more just urban alone compared to column 4, for example, the finger-like. So having a certain area that really combines built and vegetated areas in a finger-like shape. And again, here, you might be, we really need to be aware as planners and designers, we may be criticized in the sense that this will not really create a nice identity to the place. It may not be traditional, let's put it this way. Some people may talk about that, but there is a possibility to achieve all of this through very similar configurations. If you have a development that is shaped in this manner, so if you think of the white fingers over here,
that's right.
Okay.
Yeah, it works. That's right. Okay, cool.
Okay. So if you look at this, so if you look at the white fingers, this is where the houses and the residences will be, and the green areas, whatever is green, could be any type of vegetation. So you could have a water collection in the middle as a big swale and a constructed wetland with forest-like fingers of trees as well. I don't know if you know, but at the level of the city, not only at the development, if I recall correctly, Oslo is like that. It has these green fingers. Also, one of the Scandinavian countries, I'm not sure which one. This configuration is at the city scale, is not only at the residential scale. And if you actually develop those ideas, then you can have residential areas and trees coexist. And what's great about this is that it reduces the contribution to the urban heat island. That's number one. You create a lot of outdoor comfort and indoor comfort as well. So the benefits of such a scheme are very high. And at the same time, irrigating all of this is much more efficient. You can do it directly from houses rather than having huge, big water tanks to, let's say, irrigate an area like this, like a central green area, and so forth. So basically, that's my answer to you at this point, or any derivative scheme or system that looks similar to this.
Okay, thank you very much, Yaser. Any other questions from the audience, please? If there isn't anything else, I'll kind of shoot the last perhaps question to our speaker today. Yaser, we had a discussion yesterday about well, traditional ecological knowledge and about things we do, we used to do here in the Med. And I was just wondering, you've introduced today the concept of nature-based solutions. I mean, occasionally, as scientists, we kind of introduce terms and we reinvent things that have been around for years, trying to promote new concepts to people. And occasionally, we confuse them simply because they might be doing that in the past years, or they might know it with a different, term. I mean, could we say that quite a few things of nature-based solutions, whose idea is to mimic nature, done effectively in some cases with some examples in the Mediterranean?
I'm not sure I can point specific examples, but what I really can tell you, one very important piece in this story is that what we are talking about, there's nothing new about what we're talking about. We're just repackaging previous ideas, a new way to fit new challenges and new thoughts. And you might say, you might tell me, Yanis, why are you shooting yourself in the foot and so forth. But what really is the big issue, in my opinion, is this whole disconnect. Look at previous generations, wherever you are, there was always some level of continuity from one generation to the other. And there was always a transfer of knowledge in the sense that everyone sensed when the next rain is coming. We all know that, if you get these winds at a certain date and certain clouds coming from I don't know where, in 2 days it might be raining, or, for Easter there is a certain something, a certain climatic event that will help the agriculture and so forth. And all of this, and some of it may be a bit mythical, but some of it, a lot of it is true because of generational experience, because of a collective memory that really continued from one generation to other, which is fundamentally is being still connected to the land and understanding the land. We've lost the connection to the land. This is basically what happened because of the Industrial Revolution, because of all of this development that we are so proud of. And, and yes, we have invented a lot of things, but we've also forgot a lot of other things that are equally important for our daily living. When our children or the next generation don't understand very well how seasons work, I know much less than my father. My father knew much less than my grandfather. My grandfather was a farmer, used to wake up every morning at 4 o'clock in the morning, would have 2 pieces of raw garlic and something similar to ouzo early in the morning at 4 a.m., would go down to the grapevines, work until 9 o'clock in the morning and go back home and sleep, would talk to every single tree, massage every single tree, touch every single piece of soil. And I think that connection and that touch is extremely important. One example I know about that persists in Lebanon is rainwater collection, for example. There are a lot of traditional houses that actually collect rainwater on the roofs, and they maintain them there, that actually go down into pots, large pots into the ground to maintain their coolness and to actually filter them. So that's one way of conserving water that we actually need. As you said, Yanis, that's one area we are looking into, maybe collaborating and looking into. And I think that's a fundamental question for us to really understand how the traditional conventional systems were, how much of this knowledge pertains, and how can we transfer it to today, something new of nature-based solutions, basically.
That's great. Thanks so much, Yaser. So, ladies and gentlemen, I don't know if you have any last question for our speaker. If not, I will call it a day. This is the end of our seminar for today. you have found it interesting. Sorry, and there will be a couple more which will be advertised later on, and I hope we'll see you again, hear you again in one of the next seminars. Thank you so much, and thank you, Yaser, for being with us and for sharing your research, for sharing your ideas in this fantastic seminar. Thanks all of you, and have a good night. Thank you.
Thank you, everyone. Take care.